principle of coding shows an application of being able to multiply matrices together. Coding is essential for a lot of things in your life every day. You experience coding, I would guess, at least once every day in some way, shape, or form. Every time you type a text message, your cell phone translates those letters into numbers. It then transfers them to someone else's phone where they are unencrypted or translated back from numbers into letters. But in between, if you want secrets, you need some kind of an encryption to make sure that people can't read your messages. Because obviously, if I create a message, there are certain letters in the English alphabet that are used more often than others. People begin to recognize letter patterns and can see, wow, the three most commonly used letters in the English alphabet, S, T, and E. So those occur more frequently than anything else. And if I'm looking at a message that's been just translated from numbers or letters to numbers, it's not going to be too difficult for me to be able to look for patterns and be able to decode things pretty quickly. So what happens with encryption, and by the way, the second example of that is every time you use your debit card or your credit card, it translates that information that's on your card into an encrypted form so it can send it to someone else, and someone in between that gets it can't hack your account. They still hack your account somewhere, but they have to do a little bit more work for that thing. So if you want secrets, there has to be a second level of encryption beyond just changing letters to numbers. So theoretically, in our process in here, we're only going to use capital letters. Sometimes they use lowercase letters, but we use them interchangeably. In the real world, a capital letter and a lowercase letter are associated with different numbers. Every symbol that you use, an exclamation point, a comma, a period, a hyphen, a hashtag symbol, they're translated into a separate, different number out there. But for our purposes, uppercase and lowercase letters should be able to be used interchangeably. In reality, it gets a little bit more complex. By the way, this coding card here, this grid here, will actually be on your test, on the problem that you need it. You won't need to copy it down, you won't need to memorize it. It won't be at the top of your test, it'll be on the problem that you need to use. There's only one coding problem. And it's not actually a coding problem, it's a decoding problem. But I made sure you had one so that you can do your homework without having to write it out yourself. So the steps at coding a message, or encrypting or encoding a message involve your first level of translating every letter into its number associate. Now, when you do that, you tend to put the message horizontally. But in order to encrypt it to a second level, you have to reformat that message that you had on a horizontal strip into a form that it can be multiplied by a coding matrix. You will always be given a coding matrix in an exercise to use. It won't always be 2 by 2, it could be a 3 by 3, it could be something else, but theoretically, if we can multiply matrices together and we can handle that, then we can also do coding, but it takes a little bit of practice. Okay, so in this particular case, when you format your message, because your coding matrix, and in fact it tells you on the problem that we're working that the coding matrix that we're using, because now we're on the first sheet there, after that, is going to be 2534. That's what we're using for the problem we're doing now. Homework exercise. Sometimes they will keep the same encoding matrix problem to problem, but sometimes they'll change them. Within a problem, they won't change the coding matrix. When you put a message into code, the person at the other end has to know what your coding matrix was to be able to take it apart. So it stays consistent to both people on the sending and the receiving ends. So in this particular case, what we're going to do is we're going to format the message into a matrix that would be appropriate to use. Then we're going to do the multiplication problem. These are the 3 steps of encoding. And about half of the problems have that. So The next page gets us into the working part of the problem then. We're going to take this message, time in a bottle, and we are going to encode it. We're going to code it, we're going to encrypt it. We're going to put it into a format that would make difficult for someone else to be able to just look at my message and figure out what it said. Therefore, it should remain secret. And maybe Donald Trump and his lawyer should have done that. I don't know. Who knows? So, letter number translations. T, associated with the number 20. I, associated with the number 9. M, associated with the letter 13. E, associated with the letter 5. And now there's a space. Spaces are always going to be 0 or 27. When you encode, you have to use the symbol they told you to use. When you decode, you don't need to know what the space was because it's either going to turn out to be a 0 or a 27. But in coding, you need to be uniform on the sending end so the person can take it apart. So in this particular case, let's use 0 as a space. So now we have a space to separate the E in time and the I in N. Otherwise, it would just look like one great big supercalifragilisticexpialidocious type of message. You wouldn't be able to read it. I, still 9. N, 14. And now another space, another 0. Now the letter A, which is the number 1 letter, and another space, and now bottle. B is 2, O is 15, T is 20, and a second T. L is, 12? And E is, again, 5. If this was all the more coding that you did, and you sent enough messages back and forth between you and your friend, people would begin to recognize that, hey, we don't have many places in the English alphabet when we use words that we have double letters stacked together. Double T's occur frequently. Double L's, not as often. Double S's, yeah, Mississippi's got a bunch of them. Okay. Double P's, well, if you're happy you do. But I don't think we see double Q's very often. Sometimes we see double R's. So there are some things that could make it easy for a person to decrypt this if you didn't take it to a second level of encoding. And believe me, my credit card transactions, I want to go through many levels of encoding so that people can't hack my information. See, computers have made this necessity for us in real life, and they've also made it very fast so they can put it through 10, 15, 20 different levels of encryption because they're doing it at the speed of light. And you don't notice any lag time. Us by hand, one level is going to be good enough because if you can do it once, you can do it twice, 3 times, 4 times, 5 times, and we don't believe in cruel and unusual punishment. Okay? Now, if this message is going to be sent, it has to be put into a format where it can be multiplied by this. So we know up here at the top that a 2 by 2 matrix can be multiplied by what other types of matrices? It has to be a 2 by something, correct? So now the something comes into play about, well, how am I going to know what size that my coded message matrix is going to be in? Well, you need to know the number of characters that you have. And that message, including the spaces, you have 16 characters. You need to know how many rows that you intend to put that in, which is not guesswork because it has to match the number of rows that are in your encoding matrix. So 16 characters put into 8 rows means that you have to have a 2 by 8 matrix to multiply by the encoded message. Because, oh, by the way, if that turns up to be an odd number of characters, matrices must always be rectangular, and you can't cut off a letter So you have to add a symbol. And the only symbol that you can add that wouldn't change the meaning of the message would be a space. So you might have a hanging 0 or 27 at the end of your message somewhere along the line. Why didn't they put it at the front? Because they decided to put it at the end and I can't change it. So now this needs to be put into a format that I can go to the second level of encryption of multiplying. Because we go across rows and down columns, these values now have to be put in as pairs, not 20, 9, 13, 5, 0, 20, 9, 13, 5, 0, etc. because of the method of encrypting using matrices. Some questions in your homework set are actually going to ask you to do that.